Thank you to all attendees for your interest in this conference. I would also like to thank you, the organizer and extender, the sponsor of this second MENA Energy Meet, for their kind invitation. My speech is structured in three sections. In the first section, I will deal briefly with the global megatrends in the energy transition. In the second, I will describe the Center for Energy Storage and Management designed by INERCO. Finally, I will present INERCO's activities in the field of energy and environmental technology, specialized engineering, and health, safety, and environmental consulting. Let's start. To avoid the worst consequences of climate change, governments, institutions, and companies are considering different scenarios in which greenhouse gas emissions must be reduced rapidly and significantly in the coming years. Achieving a significant reduction in CO2 emissions requires a radical transition in the way energy is supplied, transformed, and used. Because the transforming the electricity sector alone will only reduce emissions by 2/3. We should not forget that global emission reduction are subject to the important constraints of responding to the strong growth in global energy demand in the coming years. Overall, global energy capacity will almost triple. The renewables will increase from 35 to almost 70% between 2019 and 2050. Process electrification and green hydrogen will have a majority share of final energy consumption in the main economic sectors: energy, transport, industrial, and buildings. On the other hand, the cost of renewable continues to fall and not only compete directly with fossil fuel options without financial support, but are increasingly outperforming them, in many cases by a considerable margin. Renewable energy is increasingly becoming the new generation being installed in different markets. In fact, in 2020, global renewable energy capacity increased by a record of 260 gigawatts. More than 80% of the new electricity capacity added in 2020 was renewable, with solar and wind accounting for more than 90% of new renewable. This is a huge opportunity, and there is no turning back. This current decentralized energy systems based on manageable power plants will be replaced by decentralized renewable generation systems. The unpredictability of availability of the sun and wind resource, as well as its variability, makes it necessary to have energy systems that address instantaneous mismatches between generation and demand, storing energy in periods of surplus generation so that it's available when there is a deficit. In this context, energy storage and green hydrogen system will be key elements that will bring flexibility to energy system and enable decarbonization and the effective integration of renewable generation. There exists a wide range of different energy storage technologies with different degrees of development, which can be conveniently categorized in 5 groups: mechanical storage, chemical storage, electrochemical storage, and electric storage, and also thermal storage. Storage application of these technologies will vary according to the different capacities and performance. Storage capacity from kilowatts hour to terawatts hour, require discharge time from seconds to hours, and duration of storage from minutes to months. The combination of these storage technologies provide a complete portfolio of advanced energy services to renewable generation systems. Hydrogen is also emerging as a key player in the transition towards clean, secure, and affordable future energy system. The production of hydrogen from low-carbon electricity has a strong potential to deliver carbon savings in otherwise hard-to-decarbonize sectors, such as the industry and transport. Green hydrogen has to overcome several barriers. The most significant barriers are the price gap with conventional high-carbon hydrogen production technologies and the effective promotion of its application. Fortunately, clean hydrogen technology have achieved a development stage in which they are ready to scale up and bring down costs, similarly to the development of the other low-carbon technologies such as solar panels or wind turbines. Regions with abundant solar and wind resources could produce electrolytic hydrogen at cost under $2 per kilograms and export hydrogen to regions with high energy demands and more limited or less attractive renewable resources. This is just the beginning of the energy transition that is accelerating rapidly, driven by sharp declines in cost, stricter environmental regulation for fossil carbon energy generation, and growing public concern about climate change. This is a great opportunity and there is no turning back. Inerco offers a new technological proposal in the field of energy, focused on the electricity generation sector and the intensive energy industry to optimize their decarbonization processes. Inerco Energy and Storage and Management Center, called CAGES, represent a decisive advance in the field of energy optimization through the use of advanced technology that allow from surplus electricity or low thermal heat, electrical energy to be stored for later use or to be transformed into other resources, such as hydrogen, steam, heat, coal, or synthetic fuels. The added value of our cajes lies not only in their capacity to aggregate and deliver electricity on demand, but also in the multiple possibilities of transformation into other energy sources through a modular and expandable technology with advanced energy management system that convert the whole set. Cajes are designed on multi-technology, modular, flexible, and scalable platform that includes energy generation technologies, electrical energy storage systems, electrolyzer for hydrogen production, thermal and thermochemical storage system, as well as heat pumps and CO2 conversion. The configurations necessarily optimized through in-house development are adapted to the needs of demand and provide energy vectors like electricity, hydrogen, steam, heat, coal, and synthetic fuels, seeking the optimal design to minimize capex and opex. Energy management system is the brain of CAGES that provides communication with the transmission system operator, power and energy market and network services management, generation and modeling of demand behavior, optimize the asset performance, use of SCADA for monitoring and control, prediction of the planned operation of the asset, and real-time planning adjustments and power set point tracking by assets. Our CAGES are multi-technology, modular, flexible, scalable platform capable of managing electrical loads, thermal loads, and CO2 streams through advanced systems to provide a set of decarbonized energy vectors. CAGES will allow a greater penetration and integration of energy from renewable sources, a greater contribution of wind power, stability of demand, better system response, and lower CO2 emissions, at the same time as it promotes the reduction of discharge and profitability by favoring an industrial symbiosis, in which energy producers and buyers are united through this system. Hybridization of power generation system combined with different forms of energy storage are currently interesting business opportunity. These applications are of particular interest for facilitating the integration of new renewable photovoltaic, wind, and biomass-based sources, as well as for the hybridization of combined cycle power plants with renewable sources. There is different cases where we have worked on for international electricity company. The first one is for a hybrid combined cycle power plant with renewable generation and storage system. Various utilities companies in Spain, we analyze different configuration with photovoltaic plants from 5 to 20 megawatts of power and battery electric storage system applied from 5 to 20 megawatts, offering a service from half hour to 2 hours. And integration of electrolyzer for green hydrogen production from 1 to 3 megawatts. For a different analysis scenario, we obtain a range of financial return with a TIRE from 11 to 13% and a payback from 7 to 8 years. Excuse me. Another case is hybridization of a photovoltaic plant with a lithium-ion battery system, sizing for customer in Chile, offering application for a mining company. The objective is to extend at least 10% of supply power until 0 hours every day. We applied to photovoltaic plant of 3 megawatts with a battery electric storage system of 1 megawatt for a service of 2 hours. Among other projects, Inerco is currently developing for a TCO gas operator in Europe the conceptual engineering, basic engineering, and property engineering, including health, safety, and environment management, and obtaining all permits and authorization for a new 100 megawatts green hydrogen production plant. I would like to share with you the key takeaways. We think that it's important to achieving a significant reduction in CO2 emission requires a radical transmission in the way we supply, transport, and use energy. The future high energy demand will be met by decarbonized energy. Renewable energy technologies are becoming increasingly competitive and business models are evolving. Energy storage and green hydrogen will be key to decarbonization and energy system flexibilization. Inerco's Energy Storage and Management Center represent a decisive breakthrough in the field of energy, optimizing the CapEx and OpEx of energy plants, photovoltaic, wind, biomass, solar, hydro, and geothermal, and supply a complete portfolio of decarbonized energies, electricity, hydrogen, steam, heat, coal, and synthetic fuels. Let me introduce briefly Inerco. Inerco, technology and specialized engineering for sustainable development. Inerco, with more than 700 professionals and companies in Spain, USA, Portugal, Mexico, Colombia, Peru, Brazil, Chile, and India, have executed projects in more than 70 countries since 1984. For more than 35 years, we have been working for major international companies in the energy, oil and gas, mining, steel, chemical sectors. Inerco develops energy and environmental technologies and provides consultancy and specialized engineering services that contribute to the sustainable industrial development. In the field of decarbonization and energy transition, Inerco develops an integrated system in the following fields: process optimization and energy efficiency, generation and use of green hydrogen, energy storage, electric batteries, thermothermical, etc., hybridization of renewable generation, and energy storage system, and CO2 capture and use. If you have any question of interest, please contact me and we will be pleased to support you. Thank you very much for your attention.